You're watching the other lesson on the Pythagorean theorem. This lesson will be talking about how to apply the Pythagorean theorem in certain types of questions. So the previous lesson talked about what the Pythagorean theorem was, what the equation is, and how to prove if a triangle is actually a right triangle. So here we see it's just rearranged a little bit differently. We have c squared equals a squared plus b squared, but you can write it that way, but you can write it a squared plus b squared equals c squared. So, what is a right triangle? Because that's what this is all about. A right triangle is any triangle that has a 90-degree angle. If it has a 90-degree angle, it is a right triangle. So, what does the Pythagorean theorem mean? So this is from our previous lesson. The Pythagorean theorem is defined as a squared plus b squared equals c squared. So now we got all these letters. What do these letters represent? Well, the letters represent the sides of a triangle. So remember, there are three sides to a triangle. So this would be side A is side A, B is side B, and C is side C. Right? So what we're saying is we take the length of side A and we square it. We take the length of side B and we square that. Well, if this is in fact a right triangle, a squared plus b squared should equal whatever the side length of c is squared. Right? So if you square every side, a and b should add up to the longest side squared. That's what the Pythagorean theorem states. So the longest side is called the hypotenuse. In our equation, a squared plus b squared equals c squared, c is always your hypotenuse. It always equals, a squared plus b squared always equals the length of the hypotenuse squared. The hypotenuse is always the longest side of a right triangle. It is represented as c on the equation. So here we have the triangle. We have side A, B, and C. You see, C is on the longest side. Don't put C here. It doesn't matter what A and B is, as long as C is the longest side, because a squared plus b squared equals c squared. Or the two shortest sides, the length of the two shortest sides squared is the longest side squared. So here we have an example where we're trying to find out, we know that this is a right triangle, and we're saying, okay, but we're missing the length of the hypotenuse. We're missing the length of side x. Okay, well, how can we find the length of the hypotenuse? How can we find the length of the longest side? Well, what we can do is look at our Pythagorean theorem. So we know a squared plus b squared, or the other side lengths squared and then added together, should equal the squared length of the longest side, or the hypotenuse. So what is x? Well, we have a squared plus b squared equals c squared. So I'm going to call for side A, right? And I'm going to call this side, the length of 3, b, right? So if a is now equal to 4, because it doesn't matter. This could be a, this could be a. It doesn't really matter, right? So I'm making 4a. Okay. Well, a squared plus b squared equals c squared. Well, if 4 is a, right, I substitute that in. So if 4 is a, then I replace that a with 4 right here, right? And I put the little 2 there because it's squared. Plus b, well, in this case, I made b 3, so 3 squared, right? Should equal x, right? We made the longest side x. We don't know what x is, but that's our c length, because remember, c is the longest side. So I go x, right? So now I have 4 squared plus 3 squared equals x squared. Just like here, I replace the a with 4, I replace the b with 3, and I replace the c with x, because c is the longest side. So I have 4 squared plus 3 squared equals x squared. So this is what my equation is. Okay, well, let's work it out. 4 squared is 16, so that's 16, right? Plus, well, 3 squared is 9, right? Equals x squared, right? because I can't do anything else with this x. So here we have 16 plus 9 equals x squared. So now we've simplified the equation even more, right? I've gotten rid of the exponents on this side. I've solved for them, right? 4 squared is 16, 3 squared is 9, so that's where I got these numbers from. And that equals x squared, or this long side squared. Okay. Now that I have 16 plus 9 equals x squared, I can simplify it even more. So I had a squared plus b squared equals c squared. I made 4 side a, so I replaced the a with 4. I made this 3 side b, so I replaced this b with 3. And I made side c x, so I replaced this c with x. So I have 4 squared plus 3 squared equals x squared. Then I simplified. 4 squared is 16, 3 squared is 9, and we just have that x squared. Well, when we simplify this even further, 16 plus 9 is 25. So we know that 25 is x squared. Now, a common mistake is people will stop right here. They'll say, oh, I know what x is. It's 25. Don't do that, because you see right here is that little 2. That little 2 means you have 2 x's here. Remember, exponents, this little exponent here is telling you how many x's you have. So really what you have is 25, right? 25 equals x times x. And so that's a problem, right? I want to find out how much 1x is. How do I find out how much 1x is? Well, if you recall from the previous lesson, this is squaring a number. Well, we do the opposite of squaring a number, right? So the opposite of squaring a number is square rooting a number. So if I square root this, and I square root both sides, because whatever I do to one side, I do to the other side, well, that'll get rid of one of the x's. So now I have x by himself, which is what I want in algebra. And then I square root 25. So here we have 25 equals x squared. Again, if I want to get rid of that 2, I have to square root the x squared, and I have to square root the 25, because whatever I do to one side, I do to the other. So now I get rid of that, which makes it just x, and the square root of 25 is 5. So now I know the length of 5 is x, and I can prove my answer, right? Because 4 squared is 16, 3 squared is 9, 16 plus 9 is 25, right? 25 is 5 squared. So it works with our equation a squared plus b squared equals c squared, right? So it's a little bit of, quite a few steps, but if you follow these steps carefully, you can't make a mistake. And as long as you don't stop with x squared equals a number, then you will get the right answer every time, as long as you remember to square root your x squared. So here we have a different question, right? Instead of not knowing the long side, we know the long side. The long side's 13, right? And this other side is 12. So we know the hypotenuse. I'm going to put h for hypotenuse. The h is 13. Well, again, our equation is a squared plus b squared, right, equals c squared. Now remember, c must always be the long side, the hypotenuse, right? So it's also c. Okay, well, it doesn't matter, again, what a or b is. I could make x a. So I'm going to replace a with x. So now I have x squared, right? Because I replace the a with x. So now I have x squared. Plus, now I'm going to replace the b with 12, because that's going to be side b now. So 12 squared. Right? So I have x squared plus 12 squared equals c squared. Now a common mistake, sorry, not c squared, my apologies. Let me just fix that. Sorry. Because I know what c is, right? 13, so it's 13 squared. So I replace the c with 13. A common mistake people will do is they will put the x in the c part. That's not always the case. Remember, c is just the long side. In this first question, x was the long side, so I put x where the c was. In this question, x is one of the short sides. And again, it doesn't matter which one you assign the short side. This could be a, this could be b, it doesn't matter. So in this case, I made a the x side. So I made that x squared here. And the b is the 12. Okay, so now we work through this. So now I have x squared plus 12 squared equals 13 squared. So I can't do anything to the x squared, so I go x squared, right? Plus, well, 12 squared is 144, right? Double checking. Oops. 12 times 12. As you know, squaring a number is multiplying by itself. So it's 144, right? And then I get 13 squared. All right, 13 times 13, 169. Right? So now I know a number squared plus 144 is 169. Well, I want to get x by himself. Okay, well again, this is algebra, and we did this in our previous unit with regarding ratio, rates, and relations. I want to get x by himself. How do I get x all by himself? So, well, first, I have x squared plus 144. I want to get rid of the 144, right? That's the easiest one to get rid of first. Okay, well, I'm adding 144. Well, if I'm adding 144 on this side, then I want to get rid of it. Well, I do the opposite. The opposite of adding is subtraction. So I subtract 144. So if, for example, I have 5 apples and I take away 5 apples, I have no apples. In this case, I'm adding 144. If I take away 144, they cancel out, right? So nothing happens here. But because I did that on this side, whatever I do to one side, I do to the other side. So I have to subtract 144 on this side, right? So I go 169. 169 minus 144 gives me 25. All right, so now I know x squared, right? X squared equals, right, 25. Now this might seem a little bit familiar, right? I have x squared equals 25. I do not stop here. I want to now get rid of this little exponent, right? I want x by himself. Well, if I'm squaring a number, the opposite of squaring a number is square rooting. So if I square root this side, whatever I do to one side, I must do to the other side. X squared gives me x, right? When I square root x squared equals, well, the square root of 25 is 5. So this length x must be 5. Okay? So that's how you solve questions where they give you a triangle. In one example, x was the hypotenuse, so x was c. In this question, x was one of the shorter sides. A common mistake you will make is you will accidentally put x in the c section when it shouldn't be in the c section. Remember, c represents the longest side. So because they gave us this long side here, 13, c is 13. This x could either be a or b. It doesn't really matter. So now we're going to take a look at a couple grids. This is another type of question you'll run into. So let's say I had 2 points on a grid, and I wanted to find the distance between this point and this point. My points are 1, 8, so 1, 8, so 1 on the x, 8 on the y, and 6 and 3. So 6 on the x and 3 on the y. What should I do? How do I find this length, right? I could count that, but that doesn't really work because I'm going diagonally, right? So it won't really work this way. I need to find the length or the distance between these two sides. So what does that got to do with a triangle? What is this line? This is a terrible line, but what does this line have to do with a triangle? Well, I could make one, couldn't I? Well, if this is this diagonal line going across, well, then I can go like this and meet them like this. Oh no, here we go. I got a triangle. So we create a right triangle by connecting the dots. I connect the dots directly, and then I go across and up. The hypotenuse will be the distance we want. The hypotenuse of this triangle we just drew will be the distance we are looking for. Okay, well, remember, we're trying to find the hypotenuse, so I'll just make that x, just like this question, right? It's now the same as this question. Instead of just being given a triangle, I'm given 2 points, and I made the triangle. And so this question gave me the triangle and said, find x, which was the hypotenuse in this case. In this question, I had 2 dots, and I made the triangle, and the hypotenuse is what I'm looking for, because that gives me the distance between the 2 points. So again, Pythagorean theorem is a squared plus b squared, right, equals c squared. A squared plus b squared equals c squared. Okay, so what's the length of A? Well, it doesn't matter which is A, because as long as C is our hypotenuse, it doesn't matter which one's A. So this could be A. Okay, the length is 1, 2, 3, 4, 5. All right, so this has a side length of 5. Well, what's the side length of this one? 1, 2, 3, 4, 5. This is also a side length of 5. All right, so now I'm looking for x. I have the two sides of my right triangle. I just pop it into my equation. No, let's make A this 5. Okay, so now I have 5 squared, right? Plus this 5 squared, right? And that's going to equal, and I'm going to replace my C with x, which makes it x squared. Not x, but x squared, because there's an exponent here. Now we simplify. 5 squared is 25, right? 5 squared is 25, plus 5 squared, again, 25, equals x squared. Equals x squared. Okay, well, I can go 25 plus 25 is 50, right? Is 50, equals x squared. Well, now I want to get rid of the squared. So here we have this. Well, to get rid of a squared, you do the opposite. I square root it, which gets rid of the squared. But whatever I do to one side, I must do to the other. So it's the square root of 50. Now, you may recall, 50 is not a perfect square, so that means it's very difficult to calculate accurately, so I'll just plug it into my calculator. So I write 50, and I square root it. It's 7.07. So we know that x equals 7.07. So this length here is 7.07. And so that is the length of the distance between these 2 points. So it's not just counting the square. 1, 2, 3, 4, 5. You would get 5. No, it's 7.07. So after we do this, we get these side lengths, right? Just like before, 5 and 5. 5 squared plus 5 squared equals c squared. Right? And then you have 25 plus 25 equals c squared. And you have 50 equals c squared. Or in this case, I didn't replace it with x. It doesn't really matter. As long as I'm solving for this, it doesn't matter, right? I could make this x. I could keep it as c. It doesn't matter. I square root both sides, right? And I get 7.7. So that's how you solve a question regarding Pythagorean theorem and the distance between two sides. So on your own, try and solve these questions. This one might be a little bit tricky, right? Because it's kind of flat, but you can absolutely solve it. All right, so try these questions, draw it on a grid, and you have the points 3 and 7, 9 and 12, 3 and 11, and 11 and 9. So practice questions 3, 5, 6, 9, 11, 12, 13, 14, 15, page 104. If you have any questions, please find me after class or during lunch. I'll be in my room. Thank you so much for listening, and I'll see you next lesson.